Hey everyone, how's it going? We're going to continue with our Pytorch CNN convolutional neural network part 3. We're gonna probably get the AI model to train today. We're going through every single Pytorch tutorial that's available to us, and we're going to become Pytorch experts. Let's do this. Let's become Pytorch experts. We've got our class that we built here with a whole bunch of fun functions in it. Some nice little debug functions to check to see that our data looks nice and clean. We've got our norm vectors, which is going to normalize all the data across the different image types. So that way, when we're converting the images from, 0 to 255 per color channel, we're going to convert it. Hey, Neva, good to see you, Steven. Hey, welcome on in. We're doing convolutional neural network today. We're gonna make it work. We're gonna train it today. Essentially, the last couple of streams, we built it up. Now we've got the full thing. We've got our data. Now we just got to run through the optimization steps, which is, the learning phase. Let's get it happening. I'm excited about this. I hope you've had a good set of days recently. Someone was in here. They mentioned you. Neva. Hey, have you heard of Neva? Yeah, they said they were related to you. They said they were related to you or something like that. I can't remember exactly what they mentioned. They said, oh yeah, Neva, you know Neva? I'm like, yeah, we know Neva. What are you saying Neva for? All right, so let's get into this. So we got our batch color channel width and height. Oh, maybe my kid brother. Yep, maybe. It could be. I'm just trying to remember their username. I don't remember their username. It had an underscore in it. It started with 2 letters, then it had an underscore, and then it had like another 6 letters or 7 letters. I don't remember the exact name. I don't know why I remember the underscore part of it. There's an underscore in it. Okay. So let's jump back. So now we're going through the tutorial. We got our classes, our labels, our output data. We showed the images. Let's run it to make sure that we're in a good state here. So let's run this really quick. Okay. Should pop. Yep, there we go. So we got a pop up here. Some image data right here. Obviously a car, a bird, a dog, and a cat. That's actually a good combo. Did I label it correctly? Am I a human? Car, bird, dog, cat. Yeah, there we go. The layer norm thing, is that used in training? It is only in training, yes. And I know you might have spotted this. You don't necessarily need to put it inside of a class like this, although we did. Hey, Zachary Hamilton, hey! I posted the line I was trying to get you to put in the Discord. Oh, really? Okay. Let's take it out. In the Discord, you said? Where'd you put it? Did you do just now? Or somewhere else? Where did you put that? Did you do that yesterday or today? Zachary Hamilton. Where'd you put it? Scroll up in general. Okay. General. Let's see. All right. So here's the start. Looking. Oh, right here. Image mean. Image. Oh, this access to. Oh, right here. NP. NumPy.mean. Okay. Let's do it. It's right here, right? Zachary Hamilton. All right. I missed your message. Okay. Let's do this. Let's make this happen. All right, let me open up a thread here so that way I can confirm that it's working or not. Let's do this. Okay. Nice. Exclamation point. Testing it now. Okay, let's try it. Do you remember to take an mocking average of the training values so you have a proper scale layer for evaluation? So this is just standard deviation and mean. Obviously, that's just to improve the scale as you're measuring and converting the image data, colors 0 to 55 down to 0 to 1, right? Because not all the images are going to have like perfect 0 or perfect full color or full no color. Hey Kevin, how's it going there? Kevin Lamp 8, welcome on in. Good to see you. And Soggy Paper Edits, hey, what's good? Good to see ya. So this is what we're doing that for norm of the vector of. I'm just calling it norm vex. You can call it whatever you want. I'm just using it right here. So that way, this actually is really useful. So that way it makes your data show up much more evenly across the available bits in a floating point value. Oh, so you're running this as a pre-processing. Yes, exactly. Exactly. Pre-processing. You know it, because when we want to convert those color channels into, 0 to 1 in a floating point number, I want, it's got to be smooth. You want smooth gradients. It's what you want in AI. Everything want to be smooth. It's all got to be smooth. Okay, on his phone, my name is Carly. Oh, Kevin Lampe. Okay, I'm on his phone. Your name is Carly. Got it. Okay, Carly. Sounds good. Good to have you here. It's me, Kurt. Oh, Soggy Paper Edits. Oh, Kurt, I can finally watch your stream. Hey. I saw your message. I posted an answer to you. I gave you a proposition. I don't know. Do you agree? Do you like that proposition? Let me know. There's no urgency on the matter. Take as long as you want to consider it. I gave you a proposition. Everyone, this is Kurt, who edits the shorts, the video shorts editor. That's Soggy Paper Edits there. You should keep the mean and standard as scalars in the model so it can be used in the evaluation, although might even be fine without it. I think we need it for, we do need it for the data. So I am going to be using in the test, in the evaluation set as well. So we're only doing training right now. We're just going to do training. We're going to see the loss drop. The loss is going to drop. And we're going to be happy about it. That's what we're going to do. We're going to be happy about a drop that's going to loss. Also, I believe the tutorial is not using, I guess, one hot. They're not using one hot on the class labels. I think I want to change that because you get better results. Man, awesome, man. I'll look into it. Nice, cool. Sounds good to me. You get better results rather than giving you, because, right, AI, remember, it likes numbers between 0 and 1. 0 to 1, and it could be a -1 if you want, or a +1, just 0 to 1 is what you want to be. Okay, so let us run this really quick. Let me see. All right, so yeah, we got our good data here. Let me see. Let's go over here. All right, let us start training the model. I think I would like to implement a train method directly inside of the class. I think that would be fun. Let's do that. This is not a normal approach. We're just messing around with it. We're making it our own. The statistics really like being normalized for it to go brr. Yeah, it does. Hey, Sobs. Hey, bro. Good to see you. Welcome on in. Def train. Yeah. Smooth. I like smooth. And normalize, right? You got to normalize that. Got to smooth those things out. Train. We're going to train itself. Okay. Pass for now. Double check. Okay. Let's bop back in over here. Okay. They did this differently than I did. Labels J classes. Labels. Oh, that's actually really neat. I didn't know that you could do that. I did it differently. Hold on. This is a nice little bonus right here. All right. Yo, I made it. Hey, Spider-Moon Toby. Good to see you. Welcome on in. Happy Wednesday. We're becoming Pytorch experts. I want to upgrade it to this. Hold on. I want to do that real quick. One second. Show image. I did a, what do you call it? The list comprehension. I did list comp. Let's do it differently. Let's do it. So classes labels J. Okay. Can you do that? Hold on a second. They also, they did it weird. Look at that. They did it weirdly. No. Mine's better. I like mine better. Look at mine. So they also did a list comp here. They did a list comp here as well. Look at that. My list comp is better. I like my list comp better. I'm like, I'm going to do mine like, no, mine's better. It's cleaner. It's easier to read. Although I do like classes labels J. I think that's pretty neat. I think that's pretty neat pattern. It's just that it requires you to use a range. This is just neat. I think this part right here is neat. You don't need to do it though. Yes, you can do a generator comprehension. Yeah, generator comprehension. I like it. This does make me happy. This is pretty neat. It's just so weird to see, right? It's so weird to see. Okay, I like this better. It's cleaner, it's shorter, and it gives me exactly what I'm looking for. Let's write the training. The goal for today, you guys, if you don't know, we're building a convolutional neural network. We built the network yesterday and the day before. Today, we're going to do the optimization phase. Optimization, right there. Thank you for the hearts. Appreciate it. Oh, hey, Mr. Arb. Mr. Arb, thank you for the lucky. I appreciate it. Thank you for the lucky. That was very nice of you. 4 jewels. What are you doing over there? My gratitudes to you. Thank you so much. Have you used indexed by Boolean yet? Indexed by Boolean? Wait, you mean like true false? What? Does that coerce to 0 and 1? Are you serious? Hold on. No, you can't do that. I think it's going to be angry at you for that. A equals 1, 2. Then A true. Can you do that? You can, false. Yeah, you sure can. Is that what you're talking about, Zachary Hamilton? Why would you do that, though? It's going to be fun for eval. Yeah, okay, got it. Steven showed indexing by Boolean on 2 different streams. Oh, I did? It did? It's not the same thing then, is it? This? I don't think that's what you're talking about. I'm pretty sure it's not. Okay. Let's bring this back over here. Let's write our training function. This is the optimization phase. Let's do this. Train the model. Okay. I'm pretty sure we're at that point now. Training your Pytorch model. I knew it. All right. Well, I read ahead. I read ahead. Let's put all the pieces together and train the model. Do I have everything I need here? We don't need to redo this. Okay, so they're redoing everything. Oh, they're normalizing everything to 0.5. Okay. You could do that too if you want. I like this function right here. I like this function. That's pretty nice. So we're loading the data. Let's also load in our test data set. Let's do that as well. Let's make that happen as well. So we've got our test data set around here. All right, so this will be self.testSet equals, and we're just gonna copy and paste this really quick here. We're gonna do a quick little copy paste. Perfect. Dude, is my life has mostly been the past 2 weeks. Good stuff. Dude, this is what my life is. Oh, really nice, monkey man. Is convolutional networks or Pytorch or AI in general. Nice. You need an array to be 0 and 1. You need to be an array of 0 and 1 or true and false of the same size as the one you're trying to index. What? Can you give me like code example? Like Zachary, give me a code example. A quick little code example. All right, test data. Let's do test data, and this is training data. Training data, like that. Okay, we'll copy paste this. That's data loader. This will be test loader. Test loader, and this will be the test set. This is train false. So that gives us our data that we want. Also, I want to do a one-hot encoding for this because I know it's going to be better. You get better results with one-hot encoding. It's going to give, because otherwise it's just going to give you a big number and it's not great. It's not so great. Oh, Soggy Paper Edits, thank you. Your streams are amazing, man. I want to study programming even more. Very nice. It's a lot of fun. It's great. It's fantastic. And if you're working with the AIs to write the code for you, you actually get a big bonus. It's a big benefit because you're able to guide the AI more directly and you can know when things are going in the direction you don't want it to go. Array. Oh, x equals 2 is what you're talking about. Got it. Okay. Yeah. All right. So we could do that here. Python. I'm going to test that real quick. We'll test that real quick. I love doing boop indexing. Wait, what's that? What's boop indexing? And C for memes, it's nicely when you have a double buffer. I've not heard about that. I don't know what a boop indexing is. I've never heard of that. I like it though. I like it. Hey, Kathix. Good to see you. Glad I get to catch another live stream. Let's go. Yeah. All right. Just to let you go, that should let you all know, next week we're going to have earlier streams because we've got some big days ahead of us. For 2 weeks, we're going to have early streams, though we'll go back to normal time afterwards. Do you practice leak code challenges too? I've done some leak code. They're fun. I wouldn't call it necessarily practice. I call it more of a game. It's more of like a puzzle. It's a fun puzzle. You can do leak code. You don't want to do leak code necessarily for learning because, maybe a little bit. It's fine though. Run some Vulkan image current. Current not equal to current. So let's say A equals, and then we'll say A is 1 equal to, wait, what'd you put up there? You said 1 equal to, well, okay, wait. x equals 2, a x equals 2, like that. Sure. Yeah. As we can see, it works. As we can see, it works. I don't know when I'd use that though. How's it going there, Spudnik Beans? Good to see you. I'm currently a student and want to know a bit of C#. Hey, very nice. C# great. I love C#. Got the .NET over there, and I dream to be a great Unity game programmer one day. Are you currently my inspiration? Hey, that's great to hear, Spudnik Beans. Thank you. That's really appreciated. Unity is fantastic. It's great. It deploys on all platforms, all targets. You can do mobile, you can do web, you can do console. Fantastic. Hey, Claude, good to see you. Welcome on in. Welcome on in. HS, hey, thank you for saying hi. Do you ever use NP new access? I've not used it before. What we're going to use right now, though, is we're going to try this. We're going to do image mean this. Let's do this real quick. All right, let's do this because Zach Hamilton wanted us to do this. Okay, let's rerun this to make sure that we're in a good working condition. We're in good working condition. Okay, looking good here. All right. Okay. Let's do that one. Perfect. Okay. Yep, that looks good. All right, we're running. We're good. Okay. So show image, we want to do this. Image equals np image. Okay, so we're going to go like this. Okay, let's try that. Let's see what that looks like. All right, Zach. We're going to do it. We're going to try it. We're going to see what it does. Is it going to like invert it or something? What's it going to do? It's going to average it. It's going to average it out. Okay. The Pytorch way of just naming it none is so much easier. Is it? It's a lot easier. You've used new access. Okay, got it. Sadly, need to go. All right, Soggy Paperhead is good as 2 a.m. Wow, you're up late. All right, go to sleep. What's up? What type of training? Oh, we are a convolutional neural network. We're doing Linnet. We're going through all the Pytorch tutorials. We're on week 2. We're essentially part 2. This is the training phase or the optimization phase of the convolutional neural network. Thank you for the hearts, you guys. Appreciate it. I see those floaty heart icons. Wait, it might be np.where equals. Oh, got it. Yes, I've used that before. Especially when doing a ReLU. When I wrote my own ReLU, I used that before. Yes, Zachary. I've done that, Zach. Nelru. Yes, exactly. In your opinion, what mainstream AI model is best? High-level coding, Gemini, Grok, Claude, etc. So Codex 5.4 is doing really good for me. Claude, Opus, doing good. Gemini, Grok, Brock, we're all good here. Yo, Steven, it's been a bit. Hey, Nathan Mycroft, good to see you. How's it going? Hope you're doing good over there. Am I late? Alexander, you're on time. You're doing good. Sorry, bro, and thank you. But bye. Meet you tomorrow. Sounds good, Claude. You love 5.4? Yeah, exactly. 5.4 is great. 5.4 is doing really good. It's doing really good. It is actually a next level of impressed. Like, wow, is it really doing that? Is it really doing that? It's actually pretty great. I'm enjoying it. Okay. Let us do this. I'm going to try this. All right, Zach, let's try it. Let's see what it looks like. Here we go, Zach. What do we do to the images? Oh, it doesn't like it. NP images is not defined. Yeah, it is. It's right there. Oh, it's image. Okay, got it right here. It was just plural. Okay, I copy and pasted. I shouldn't have copy and pasted. I should have followed the instructions. It's still not working. Oh no. Okay, we'll figure it out. Hey guys, good to have you here. I love Numpy. Yeah, Numpy's good. Hey Loons, good to see you. Welcome on in. Did you first learn coding? Yes. Spudnik Beans, coding first before AI. AI just is like the most difficult coding. Like if you're looking in software engineering, the most difficult tasks I would think are game development and code and AI. Those are the big. And then of course big data and analytics and then heavier algorithms. Those are pretty big. You're so confused. How does Pytorch work with AI besides predictive analysis? It is all about predictive analysis. That's all it is. That's the whole thing. It's a math where you do statistical regression in multiple dimensions across your data set to predict specific answers. So you have a certain data set, you have answers to the data set, you give the model training data so it can learn on a training set, and then you give it new data that it's never seen before, and it can give you novel answers. That's the whole point of AI. Torva! Hey, Torva, welcome on in. Good to see you. Going great. Glad to have the live coding. Yep, Nathan Mycroft, good to have you here. Let's see. I enjoyed the Quinn 3 coder. Oh, you use it through Olama. Nice, monkey man. That's great. Where did pickle come from? Why is it pickling? Wait, what? You mean Python? In Python? What's the state of the CNN? The convolutional neural network has been built. We are just going to optimize it today. That's the actual training. Hey, Mark Lemon, good to see you. Thanks for saying hi. The compilers, OS stuff, and CUDA kernels are also very hard. Yes, good point, Neva. You bring up a good point. So most difficult things. Hey, Spark Coder, welcome on in. All right, so what are the most difficult things? Actually, you know what? This is a good question for the polls, you guys. All right. What is most difficult coding things? All right, what is most difficult coding? We're going to say AI/ML. We're going to say big data. We're going to say OS. How many options can we have? Oh, we can only have 4 options. Okay. What was the other ones? OS/ASM, like assembly and things like that, operating systems. Maybe game development, game dev. Okay. Oh, there's other things. Don't get me wrong. There's other things. I'm curious what you all think about this. Kernel and Malbolg. Yeah, Kernel and Malbolg. Yeah, Torva, of course. I didn't add that one in there. Compilers. Oh, I should have mentioned compilers, you guys. Assembly is easy for you, Joseph. Joseph, it's easy for you. Assembly is pretty straightforward once you understand the patterns behind it. Mostly memorizing some of the common operating system calls, I think, are pretty good. And especially when you're working with assembly, you only have you're building for a specific target. Unless you've got a LLVM in front of that. That's, of course, your intermediate LLVM. You're probably not dealing that with directly. Good to see you guys. Welcome on in. You have a decent understanding of coding? All right, that's good to hear, Rush. You've built a few projects, and you're ready for AI. All right, let's do this. Hey, Black, how's it going there, Blake? Oh, Blake O'Brien. Welcome on in. I feel like there's some overlap in big data and ML. Yeah, there is nice. Yeah, there is. There's some data. All right, so let's see. Why is this not working here? We might not be able to get it to work. It's perfectly fine. It's perfectly fine if we don't. Let's see here. What if we do this? And then we delete that. Oh, no. We keep that, bring that back. And then we put np image here. We don't transpose it. We just do this. Like this. All right, let's try that. We'll undo everything. It's no big deal. Compilers can be the hardest. It requires both math and more advanced than bachelors in math as well to get a low-level knowledge. Yeah, okay, that makes sense. That would make sense. Would you rather study how to integrate large ML systems, DevOps, or machine? For me, I like DevOps. I've already done. I like DevOps. I like big data. I've already done those things. Right? Thank you for the party poppers and the hearts, you guys. I've already done those things. So what I like to do right now is AI, because I haven't fully done those things. I've done DevOps and big data for decades. I've done that for decades. Like big data. Not like, medium data, like big data, like mega, big data. Distributed systems. Yep. That's my whole company. Big distributed systems. Depending on what language you're compiling and designing, yeah, it sure makes sense. The error is because you lose the third dimension when you run on your line, so your transpose, it will error. Yes, okay. So let's see if we can show the image like this. We'll try. Which language is your favorite? To develop in web. Oh, yeah, okay. So we did that. I don't know if that's what you were looking for, Zachary, but it is pretty neat. It looks pretty neat. You're averaging all the colors across all the images. We actually got this working yesterday. I remember. It no longer looks like a cat or dog or frog. It's an average across all of them. So it's a cat, dog, frog. A double on the dog side. Favorite web development is definitely JavaScript, obviously, for web development. Why would it be anything different, Spark Coder, for web development? Maybe you're talking about server side. Server side would be Rust, Python, and JavaScript as well for web. Oh, yes, that's the hard stuff, is it? Distributed systems, especially when you have NUMA. Wait, what's NUMA? Hey, Keller, good to see you. Welcome on in. Thank you for saying hello. Would you say big data is really tedious? Not hard in itself, just starting with the problem and trying to find patterns. I like that. I like that discovery process. I'm really into it. I like it a lot, and it's really good. I even have a patent on it. I've got a patent on it, you guys. I do. Hey, Mark Lippman. Hey, how's it going? I try hard. Welcome on in. Hey, Steven. Good to see you. You created a trading strategy using Python. Hey, nice. Can I run it through the Claude to optimize it? Yeah, you should. Although be very careful. You need to know what it's actually doing. What is it doing? You got to know. Non-uniform memory access. Oh, got it. Dang, nope. I'm trying to get it to convert from color to grayscale. Got it. Okay. No worries. Here, I'm going to undo those things for now because we do got to get going. So I'll leave that here for now. I'll just leave that commented. Let me double check that everything still looks good. And then we're going to go. EDA is very fun. Oh, the good old EDAs. All right, now the images are back to normal. Back to normal, you guys. Addressing overfitting and class imbalance in machine learning. That's a pretty hard one. It is. I like to you got to make sure that all your input data and all your layers and all your activations, keep everything nice and smooth. You like smooth. It's got to be smooth, you guys. Basically, compiler can make it look impossible because why not? Why not? Exactly. I'm trying to get. Okay. Perfect. All right, let's get this going. We're gonna do training mode now. We're gonna do training. Let me get our training set loading here. Okay, so we got our training set. We got our loader. That looks correct to me. And we need a new transform. So I need a one hot self.one-hot equals a. Can we do trans? How do we do that? We need to convert a tensor into a ones. So we need a ones, and then we need to update the ones with the length. Okay. Torch dot ones self dot classes. Where's that at? Class number of classes. Okay. Like this. Let's construct it again. We'll construct it from scratch. So let's do this. Python import torch, and then we'll say torch dot ones. And we're going to say, like, it's 10, right? Okay. Let's do zeros instead. Zeros. Zeros like that. Can we do zeros with an E? No, it doesn't like that. Okay. And then we need to update one of the indexes with the actual class. So how do we do that? We did it before. Class imbalance with solving either duplicating the smaller class or just using all the samples of the big classes. So what we're doing is we've got a class system here where we've got a bunch of pictures. We know what their possible labels are and the answer positions. When we get the label data loading from our training set here, right here. So what we want to do is convert the output from the labels, which is going to, like, for example, right here. I don't know if you can see that on the screen pretty well, but we're going to get our labels, and it's going to return numbers. And we need to reference those numbers with our classes because it's going to be the index. However, when we're training our model, we want to train on the output with numbers between 0 and 1. In order to do that, you need to create an array. That array needs to have the same number of classes in it. So we're going to have an array that looks like this. Right here, and only one of the values is going to be active. Only one of the values. So a equals a, so you say 4 equals 1, and then you see, for example, you can see here that there's a 1 right there in the middle, for example, right there in the middle. And that would be, in that case, number 4 would be, in our class section, would be 1, 2, 3, 4. Or 5, actually. It would be the deer. It'd be the deer. You think numpy.oneHot method? Is there a one-hot method in numpy? Is there? We're using Pytorch, though, so we don't want to jump from a tensor to a... We want to keep everything in tensors. Steven, you may want to do a torch class equals 4. Oh! Okay. Yeah, I like that approach. Never. All right, let's do that. Okay. Yeah, torch has one hot. Does it? Torch has one hot? Let's see. Let's see here. Torch.one. Hot? How do we see that? All right. Dir torch 1. It has ones like, and it has ones as clone, lazy clone, none type. Hey, Lauren, thank you. Hey, Lauren, good to see you. It's been a while. Hope you're here. 1_hot. Got it. 1_hot. Let's try this. Torch 1_hot. _hot. Lauren, thank you for the membership. Good to have you back. It is not Torch. Has no attribute 1_hot. No attribute 1_hot. Is it .nn? No. Is it transform? Is that what it is? Torch. Torch.transform. Wait, transform. All right, it's not that. What? Weird. I don't know about that. Yeah, it's weird. Hey, we're going to find out, though. Don't worry. Where's our transforms at? Oh, torch vision. All right, let's try that. It might be here. Okay. Copy that. Bring that back over here. Yep. All right, so transforms dot dir. Let's do dir. All right, what do we got? I don't see it here. I do not see it. Maybe it's in torch vision. Torch vision. Import torch vision. Okay. I don't see it there either. Where's the 1_hot? Oh, it would be great to use it. If the framework has it, we want to use it directly. Anyway, for the solution to work, so who cares? Yeah, we're gonna try. All right, so we're gonna do torch.tensor, and we'll say x equals class for x in range. We'll say 10, like that. Okay. One. We'll try the true false. We'll try the true false. And our class is going to say 4, for example. Okay. Tensor, comma, d type equals torch.float 32. Okay. Generator expression, parentheses. Oh, it's got to be parenthesized. Can we do it in an array like that? No. It seems like we should be able to do that right there. That seems like that's something that should be able to be happened. There we go. Okay. Hey, there we go. Now we're into it. That is a really nice approach. Okay, Neva, thank you. We got it, you guys. What if we delete the D type? It's going to automatically give us... Oh, so it's going to do true, false, unless we do D type. There we go. So we just created ourselves a nice little transform right there. We do have to go a step further, though. We do have to do a step further. So I want to bring this down over here. Paste that in. Okay, so this is just part of it. That's part 1. We got to do a lambda now. Where's the transforms at? All right, so transform.lambda. All right, so this will be a... No, we need the number of classes here. This will be right here for the range of 10. And this will be our although, wait, yes, okay. Class. Let's open this up. We've got another file around here. Hey, SQ Lighter, good to see you. Welcome on in. Happy Wednesday. We're building our convolutional neural network. We're becoming Pytorch experts. We're going to do it. We're going to become Pytorch experts, you guys. Yes, exactly. Lambda X. You got it. Exactly. That's my brother. Oh, SQ Lighter. Oh, that's right. That's my sister. Hey, look at that. You guys are together. Oh, finally. All right. You were here the other day. I'm like, Nevo just joined here earlier on the stream. I was like, hey, someone claiming to be your sibling was here the other day. We were just sitting next to each other. Hey, that's amazing. It's good to have you guys here. Let's become Pytorch experts, you guys. Let's do it. That is amazing. That is quite impressive. I don't really think that's neat. After so long, that is amazing. I like that. All right, where is that? Where did we put that data? Yes, it's called custom data set. All right, so this is our lambda right here. Okay, let's make sure we got that. Where we got that. Vision transforms, and we're gonna do transforms as transforms, and then we could do transforms.lambda. Okay, so this is where we're gonna get our lambda at, I believe. All right, so .lambda right here. Okay. And I believe we can simply, we keep it really simple, right? We just do lambda. It takes one parameter, x, colon, and then we just return this right here. The torch tensor. I think that's it. Like that, boom, done. This is it right here. I'm pretty sure we did it. We're gonna make it look prettier though. We gotta make it look prettier because it's a bit much. It's a bit much to see there on the screen. Sibling, sibling, sibling. This is my brother. The classic song. Yeah, that's awesome. Used. Wait. What do you mean? HS like lambda? Yes, exactly. So it's both. It's lambda lambda. We got double lambdas here, you guys. All right. Let me make it pretty so that way we know what's going on here. All right. Bring that over here, and then we're going to put our list comp here. It's not called class. It's going to be called... Oh, we can't do X here. We have to call this CLS. No, we got to call this something different. Label. I'll just call it label. Let's just call it label. Right there. Label. X equals. Perfect. Okay. Let me pull this back over here. Nice. Now here's our one hot. One hot transform built and ready to go. Right there you go, guys. Oh, hey, Loons, I missed some of your messages. Sorry about that. I think creating your own language and compiler is the most difficult. I personally prefer cybersecurity. Why did you choose Stephen LB? Because of my name. I get the Stephen part, but not the LB. My last name is Blum, and then it's got my middle initial. You didn't update the GitHub repo of the tutorials. Oh, I sure didn't. Loons, you're right. Okay, let me do that real quick. Close that out. Git status. Git add. Oh, we don't want to add the data, though. Git add CNN, git commit dash message, updated CNN, almost ready for training. Okay, push to the main. There you go, Loons. Now it's all updated. You're good to go now. How's it going there, Anasazi? Anasazi, Onyx, or Pytorch, or mix. So I used Onyx yesterday. And it was slow, and it should supposed to be faster on the CPU. It was slower. I don't know why. It's supposed to be faster. I was using it and it was just slower. Something was wrong. I don't understand. Or mix, or doesn't matter. Kind of overlap, so also complement on each other very well. I've mostly just been using Pytorch. Pytorch was just a lot faster. When I tried Onyx, it just didn't work very well. Answer some questions for YouTube. Music, yeah. I printed out a Git cheat sheet. HS. Seems like a pretty good way to go. You got a few Git commands, right? You get status, you got Git init, you got Git commit, you got Git checkout, you got Git branch, which we're on the main branch, right? And you got, that's about, and Git merge. Those are all, I don't use any other methods. If there's another method, it's like once a year. Git switch, yes. Git switch is the new one. Git switch is the new one. Yeah, I used Git checkout because I'm just used to that. Git switch is a lot easier to use. I haven't trained myself on it. Even though it's even easier, I just use checkout. Okay. Let me confirm that we did our Lambda properly so I don't run into any errors. Yep, we did. Right there. Lambda looking good. I call that a Lambda looking good. I think that's fine. Here's our old zeros. Torch zeros.scatter. And this is our new zero. This is our new one hot. So here's the old one hot up here. This is the old one hot. Let's compare the two really quick. Let's compare the two. Lambda, scatter. All right, so this looks a little bit cleaner. This is the one. So this is the one I was going to do. Although Neva's is more of the, I like Neva's. This is like more traditional Python. This is more Pytorch specific. So this is more Pytorch here. This is more Python here, Pythonic between the two. So that's between the two, you guys. We're gonna try out this one. If this one doesn't work out, we're gonna try this one. Let me undo this, copy that real quick. And I'm gonna put it here just in case for later, just in case we want it. Okay. Facebook AI are amazing, and that's what they use. Anasazi, is it? Oh, they use Onyx. Well, oh, really? Facebook built Pytorch as well. That's where Pytorch came from. Pytorch comes from Facebook, right? I assumed they would want to use Pytorch more. Okay, let's keep going, you guys. So we've got our one hot, and we need to do our transform. What was it called? There's a different kind of transform here. It's called transform target. Okay. The transform target equals self.one hot. Like that. Okay. Same here. Okay. Let's load this and make sure it works. No, they use Pytorch. Yes. Oh, yeah. Facebook uses Pytorch. Yeah. Facebook is using everything like React and PHP and Haskell for the same website. Haskell ... Really? Are they using Haskell? Let's try this. Is it going to work, you guys? Or are we going to hit an error? All right, we hit an error. All right. Got an unexpected keyword. Transform target. So it might not have been that. Let's find out what it's actually called. It's going to be custom data transform. Where is that at? Yeah, a target transform. Okay. I inverted the words. Let's try that. Like this. Okay. All right, let's try it out. Let's see if it works. How's it going there, XD? Good to see you. Welcome on in. Oh, good. Okay. So we made progress. We made progress. Right. Okay. We can't do show images if we transformed it that way. We need to do an argmax now. Let's update this. Let's update our image show for argmax. Labels. Let's see. Labels equals argmax. Let's do argmax, you guys. XDev, thank you for subscribing. Welcome on in. This is the channel for software engineering. We're building ourselves Pytorch tutorials, convolutional neural network today. And we will learn every single tutorial live on this stream. That's the plan. Every tutorial, all of them. All the Pytorch tutorials. We're going to become Pytorch experts. That's the plan. Let's do this. The spam filter has Haskell, I believe, which is like Lamau. Interesting. Yeah, I'm excited about it. This is one thing. I've done a lot of AI in the years, mostly from scratch, because I did it before the frameworks existed. The frameworks have all the math built in for you. You just need to know what methods to call and how they work together. That's why we're learning Pytorch. Let's make it happen. Oh, nice. Yeah, I think it's great. All right, so we need to do argmax here. Can we do labels? Labels.argmax. Can we do that? Is that something you can do? I don't know if you could do that. It's probably not. It's probably gonna be like, no, you gotta use torch.argmax. I think so. Yeah, it doesn't like that. Okay, let me print that out. Oh wait, no, that looks alright. All right, labels. No. Okay, let's print labels and return so we don't get the error. We'll just return straight up like that. We'll do before and after. Before and after. This is how you debug in the real world without AI. That's also something that we do on this channel. Obviously, we're building AI. We're doing it as a human, though. We're doing it as a human. That's really odd. It printed both. It actually worked. It just didn't do anything. Torch. We might have to do a list comp. Argmax. Labels. Like that. There we go. Okay, let's see if that did the trick. Is that what I wanted? Yeah, I think so. Okay. And it's still not argmaxing. It's just why is it passing through? Why is it straight up passing through? This is very odd. Let's just print this out like that. Okay, let's try it like this. How's it going there? All with Vire. All with Vire. Welcome on in. You would like it if the distributed Pytorch wasn't so memory unsafe around cache coherence. Ah, some unsafe cache coherence? Distributed Pytorch. Why is it unsafe? Is it because transmitting the data has some, like, clipping? Is there, like, clipping? Is that what's going on? We got some clipping? Okay. This didn't do anything. This did not do what I wanted it to do. So, let's instead, we'll go into NumPy, labels, for ln labels, we will do argmax. Like this. Okay. That should give us what we're looking for now, I believe. I think that'll do the trick now. Okay. For, no, this is in the wrong spot. For L. Like this, okay. There we go. Now, that's what we want. Axis 1. Oh, we might want Axis 1 return. Oh, all right, let's try that. HS, let's do it. Thank you. I forgot about Axis. This is why we're learning together. Thank you, guys. You're fixing everything for me. All right, I'm going to copy that really quick, and we're going to undo everything. Paste. Comma, axis equals 1. Okay, let's try it. Oh, like that. Okay. All right, let's see if it works. HS, let's see if it works. Did we get it? We did. Hey, thank you. Oh, they're all tensors now, aren't they? They sure are. Okay. Do we want them to be tensors? Are they labels ahead? They are already a label. Okay, perfect. Okay. So I think that's the answer. I think you did it. Why is it printing? Oh, got it. Which one's the good one? We did, which one's the right one? So this is the second one. So let's do labels equals. We'll try this one first. Okay. Let's see if that did the trick. What we should see is success, is what we should see. We should see no errors. If it's got an error, then we got to try the other. Oh, hey, that worked. Hey, HS, you win. HS, look at that. You succeeded. Thank you. Good job, HS. Anasazi, Pytorch is lighter weight than Onyx. Oh, that could be why it's slow. Okay. I was wondering about that. I'm like, I thought Onyx was supposed to be a smidge faster. And is this Python? Yeah, it is. Xdev. This is Python. You got it. Hello. Print hello. We'll call you xdev with 3 E's. Hi, exclamation point. There you go. Oh, wait, we got to close that. There you go. Xdev right there. Okay. Let's pop back into our code editor. We fixed that up nice and clean. There we go. Yeah, it usually doubles in size when using Onyx. Oh, that's what happened to me. I was like, why is it it's doing what I didn't want it to do. And I was doing a bunch of optimization work. Actually, in AI world, we're doing some real AI work in real life, IRL, at my real job. Okay, so let's pop in over here. Now we're good to go. Everything's working, and we got the one hots. So we did it. We've got all the correct data. Now let's continue on with our training. So we've got our classes, we've got our test data, training data. We did the image show already. Obviously, we don't need to redo that. Data, iterator, show image, all right. That's what we just did just now. This is our model, so we've got a different model here. So this is our model right here. We call it Lynette. They're calling it net here. Wait. They did a pool here. I like this idea. So wait, they're doing pool 2 at the same time. They changed it. It's different. This is different than I have it now. It's different, you guys. Open Vino is usually around equivalent or slightly faster, and it never crashes. I don't know about that, Neva. You think it never crashes? I highly recommend Open Vino. Open Vino. Open source toolkit for optimizing and deploying AI inference. It's those inference. Oh, okay, got it. Inference optimization boosts deep learning performance in computer vision, automatic speech recognition, generative AI, natural speed. Okay, flexible, broad. All right. So Open Vino, a little bit better. So with Torch and Open Vino, OV. Oh, okay. Oh, I might try that out. Thank you. We'll benchmark it. I was doing some benchmarking yesterday. Open Vino. Yeah, I can move memory to disk if needed. Pytorch crashes as soon as VRAM is done. Okay. Good news is we've got plenty of VRAM, so we don't have to worry about crashing from that perspective. We just want speed. I need raw speed. I want it to go as fast as possible. I want speed, you guys. All right, Open Vino. I'll keep that open in this tab, so that way I remember it after stream. Okay. Let's keep on going. Neva, thank you. That's really good advice. So, I like this. This is cleaner. This is a lot cleaner. Do you want to see what ours looks like? Ours looks like a little bit different. So we've got this. This is what our model looks like here. However, we didn't get the activations, and we didn't do something else. Let me bring the forward up top so we can read the forward a little bit better. This is what our forward looks like. Our forward is right here. This is ask the AI to answer based on input. This is like the input. For speed, go native. Oh, well, yeah. Yeah, that makes a lot more sense. Yeah, we should go native. That would make it even faster. Okay. We could do that. We could do conversion to native. I might do that. That actually might be the next phase. It might be. Yeah, we might do that. Good idea. All right. Anasazi, yeah. When I'm thinking native, I'm thinking Rust at that point. I'm going to go Rust. We'll go into the Rust zone. So here's what this looks like, because I've got my max pool defined separately. I would like to change it up, though. Let's change it up, you guys. Let's create our pool here one time, and our ReLU as well. Do we want to do that? Conv1 ReLU pool. So it's very similar. It's very similar. Our view looks different. It's fixed. They fixed the view based on the input data here. Okay. Our linear right here is different. Okay, yeah. OpenVINO also has a good quantization framework. Oh, that's native code. Hey, that's great to hear. It's pure C++. All right. 0.637 millisecond. Microsecond? Are you talking a microsecond using Go native, and that's with your AI? That's using your AI? You have a demo, and it's really impressive. You got to go to using with Rust. Yeah. Yeah, go with Rust. Yeah, have a go with Rust. There you go. Now we're going all the way. Floor it. Make it as fast as possible. Like you can do OpenVINO and not even do Python if you want. Oh, really? Pure OpenVINO. Okay. All right, so I've got a couple options in here. We can go pure native, obviously, right? We'll do Rust. And then we could do OpenVINO. I'll look into OpenVINO to see if that makes things faster, Neva. Thank you. All right. I am okay with this. We get the input. The only thing that's different is our max pool is changing. It's changing. Can we do this as well? Can we do this? Is that the same thing? I bet you that's the same thing, isn't it? Can we do that? Hold on. Wait. Are we using the forward function at all? Yes, we are. We're using the forward function. Right here. Print out. Okay. Let's not show image. And let's run this. Let's run this, you guys. Oop. Nope, not that one. Here we go. Pytorch. Yeah, there we go. If you want to make AI faster, you probably need to good matrix multlib. That's, yep. The matrix multiplication is the expensive part of it, isn't it? Rust has one. You've never benchmarked it, though. All right. We'll have to check it out. I think we'll be good, though. Okay, let's keep going. All right, so that looks proper to me. Everything looks good here. What is this? I see a warning. A line should be passed as Pytorch numpy boolean to get a line 0. Do you mean to pass a tuple? Oh, is that where we did? Hold on. What line is that on? I want to fix this. La la la. Let's see, where is that at? Load.pickle. Oh, this is the pickle thing you were talking about. I don't know what this is. Did you mean to pass a tuple to create a subarray type? So we just did that here. Let's redo this. Let's make this a tuple again. 2. And we'll go, this is also a tuple. Let's make sure our data is looking correct here. Should be good. No, we still got that weird error. Though we still got data output on the side. Okay. Where does it want it to be a tuple at? Where does that? How about if we just return an array? Like that. Let's see if you do that. Yep, okay, so there's still an error, so that's not where the problem is. Okay. Where's the problem then? If it's not there, where is it? Is it on unload data? Let's try this. Okay, it is. Okay, so it's in here. It's somewhere in the load data set. Is it target transform? Let's find out here. We're gonna make this good, you guys. I want the error to go away. It doesn't say what line it's on. So instead, how about we return? Let's see. Let's just return this here. Return like that. Okay. All right. So that's still. So then maybe it's our one hot. It also might be our composition. Okay. It might be this line right here. Let's try it. All right, we found it. It's right here. This is the problem right here. Okay, how do we fix that? It looks fine to me. I mean, shouldn't that be okay? You're using Python plus C. Yes. You right, Roz. Roshan, you got it. Yes, we're using Python, and the underlying library Pytorch is written in C++. So that's how we're getting the power. That's how we're making it really good. What if we got rid of this? All right, let's try that. All right, let's try that. How's it going there, Night Hunter Crazy? Good to see you. Welcome on in. We're gonna do AI training today. We're actually doing AI training. C++ and Python are like the best of friends. Well, C and Python is actually written in C, right? So they gotta be good friends. They kiss and go to the park together all the time. Yeah, they do. XDev. I'm tired of waiting regression AIML in C, and it's the first I'm seeing Python in C. Wait, so you're tired of the regression in AI and L and C, and it's the first you've... Why are you tired of regression? I mean, that seems like it's perfectly fine. All right, so is it this function here that's having a problem? It's this right here. Okay. Yeah, C++ are all the friends. Yeah, they are. They're good friends. Okay. Oh, wait. So... Hold on. Wait. Return. Let me check. Okay. So... Let's close that. Let's read this real quick. Try that one. Okay. So it looks like we got a couple problems. One is here, and another one looks like it's here. Let's try to fix this. Oh, no, I was wrong. This one's perfectly fine. Let us go. All right, let's load that. Let's double check. Gotta double check, you guys. Gotta double check. You do hardware programming using Verilog. It's kind of difficult. Similar to assembly. You're doing the tough work for us. Hey, Roshan, can you use the AI to write that stuff? Is it possible, or the AI is not good? They're only good at like higher level languages, Python, JavaScript, sort of deal. Roshan, can you use AI to do that? I'm curious about that. If two languages aren't friends, surely something could be made to make them friends. That's right, Nice Monkey Man. You sure could. If you do write C normally, it's a bit of adjustment if you aren't used to it. See, I can see that. Okay, so our problem is here. It's the normvex function. That's where the problem is. Wait, before I check, I'm gonna double verify. So the problem is right there. Yes, it is. Okay, perfect. So let us do some logic over here. Okay, so where is the problem at? So is it here? Let me say return none. Curious about this. Oh wait, what I should do is, where's this being called out? Okay, well, let's call it here and return. Okay. Operating systems is in C, so the drivers for graphics are for C. You gotta talk C, you sure do. You created an AI accelerator chip. You created C logic and to write the logic using Verilog and converted it into a chip. Recently won a hackathon. Ooh, you're doing the good work there. You're doing the good work. Wait, that didn't have an issue? Hold the phone, really? Oh wait, that doesn't have an issue because we already cleared it out. Okay. Right there. Okay. How about here? Like that. Okay, it is. Okay, so the problem is right here. Okay. So it might be return. Okay. We're locking in, you guys. We're locking in. I know nothing about coding. Still find it entertaining to watch. Hey, thank you. I'm so glad you're here. We're gonna make the AI work today. The goal for today is before we end stream, we have to train the AI, and we're gonna do it using the tutorial. We're gonna use the tutorial. We're gonna take it a step up. We're gonna notch it up a step. We're gonna make it a smidge better. So the tutorial, obviously, you see we're running into errors because the tutorial we found out previously it's got some bugs in it. It's broken. So, hey, I'm new here. Hardik, Hey, Hardik, you're not new here, are you? Or are you a different Hardik? I'm pretty sure you've been here before. I've seen you. You already left the stream and just scrolled on shorts, just streaming, appeared again. Oh, did it? SQ Lighter, you're back. All right. Welcome on back. Good to have you here again. You want a high level language? All I see is instructions in machine language like zeros and ones. Sysc, risk, arm. Oh no, jumping to Python recently. That's a big change. That's a big change. SQ Lighter. That was pretty funny. Okay, so where is our challenge at here? We're back. Okay, so it's not here. Double check. It's not there. Looks good. Okay, so it is going to be here. It looks like. Okay, I believe the answer is there. And it is. Okay. So here's the problem. La la la. Is it this? Can we do that? Do we need to compose? We don't need to do a compose. We can just do a transform like this. Let's try that. Let's see if that makes it less unhappy. Nope, that didn't help. That did not help. Why are the other ones good? Why are these fine up here? These don't seem to have a problem. Right? There's no problem with these. They don't care. Okay. Oh, Roshan, thank you for subscribing. I appreciate it. You joined the right channel. We're going to be building software on this channel for a long time to come. That's the plan. We're going to do it. We're going to become Pytorch experts. That's the current trend that we're on. That's the path that we're going for. We want to become Pytorch experts. Every single Pytorch. Your college AI courses have risk. 5. Joseph. That is a pretty decent assembly. Risk, I think, is pretty good. Bro, I'm the same Hardik. I thought so, Hardik. But it was like 1 to 2 weeks ago. Damn, bro, I'm impressed by your sharp memory. Yep, Hardik. I'm like, I recognize your name. I knew it. I knew you were. I'm like, you're not new. You're not new. Okay. Well, it's because we're coding, we're chatting with you guys, and we're trying to debug, and we're also reading the tutorial, which has bugs in it. We're like, that's a bug right there. And we're currently debugging this new one. Okay, let's keep going. So that by the end of the stream, we are absolutely going to have a full-on working training model. And we're going to get, at the minimum, we're going to see the loss. We might test it on the test data if we have time. Okay, so where is the challenge at? Got a warning on a line should be passed with Python, NumPy. Got a line 0. Did you mean to pass a tuple? Okay, so right here, this is the data set here. Okay. Where is that at here? So I want to see here. Okay. This right here. All right, 1 second. So it is in that. So it just might be that loading this data set right here is having an issue. We might have to do a quick little lookup on it to find out. You just subscribed again? Why didn't it show the notification, Hardik? It's because it's selective. It doesn't always show the notification. I want it to. I sent them an email, a support email, like, hey, why isn't it showing the notification? They're like, we don't know. Yeah, they should. It should always show, I think. AI isn't hard coding, it's just hard math. Dina, yeah, sure is. We got some hard math in here and a whole bunch of data preparation. It's a lot on the data preparation side. How many parameters are you going for? I think this is around, where are we here? Density, where's our density at? Density is right here, 120. So, calculator, it's like a few million. I think it's a few million. Not a lot. Oh, I mean, it is a lot. It is a lot. So it's a few million. We could math it up. 120 and 120 times 100 times plus. Yeah, so it's a few million. It's a few million. It can be art of coding if you're writing the matrix on a GPU. If you're doing it on GPU, yeah, you can. It's my favorite song. ML is mostly data prep. That's right. Nice monkey, man. That's what we're doing. Data prep. That's actually the problem we're working on right now. It's the data prep part of it. Are you a college student or employed somewhere? Yes. If yes, then where? Yes, Hardik, yeah. Coherent memory is ridiculous. Good old coherent memory. I have my own company. Hardik. Let's see. All right, so if you guys are curious about it, let's pull up my screen here. And is my face gonna show up? All right, there it goes. Let's zoom in. Here we go. So this is me, you guys. My name is Stephen Blum, CTO at PubNub. Started the company over a decade ago. We raised $134 million. Series E, 1 billion devices, 68 patent claims that have been granted. They're on my LinkedIn profile. You can see it. Been in tech for 25 years, Hardik. What does it do? Well, I've got this ready for you to go. We power social media entertainment, where you see live updates, multiplayer games. Have you ever played a game on your mobile phone and with another person? Have you used telemedicine with Teledoc or other telemedicine features? Have you bid on anything live on the internet? Have you seen live stock quotes in person on your phone? Have you seen those things update? Have you chatted with a call support center? Or have you pressed the order button on your phone to see any updates as the car moves closer to you on the map? Do you see that? That's what we do. You write kernels from scratch? Yeah, well, Neva does. I know Neva does. I've done it before myself too. Write kernels and most of the math, and then you just have some optimizations with shared memory, but then it's not harder than OS coding. I think it's pretty good. I've done it before. I like the threads. That's my favorite part, is working with the X thread, the Y thread, and the Z thread. The variables, you think you're not sure what they're for. Actually, when you're doing AI/ML chip, it's dedicated hardware. Doesn't require more RAM or ROM. Just power up the chip and you get your AI application output. Electronics level AI. Ooh. What does data prep do or mean? XDiva. Data prep means that we take all the data like an image, and then we need to make sure to normalize the data, which means it's all in the same shape. Then we have to convert the colors into vectors. Instead of being two-dimensional array, we need to string out all the pixels into one long line, because that's how AI reads. Then we need to turn every pixel into a number between 0 and 1. So we got to normalize it. That's data preparation. It's a lot of data preparation. Oh yeah, like another Linus Torvald. Reading the kernels, you guys. So many kernels. I like AI kernels. I think they're great. You keep me on. It's the third time now. Hey, SQ Lighter, welcome back again. You can't get away. There's no way to escape. Alexander, OMG. I'm trying to start my agency. You really seem like a person who can guide me. We can connect on Discord. Yep. Hardik, are you on Discord? Let me go here. Just in case you're not, I'll copy that over to you, Hardik. At Hardik. There you go. Happy to connect with you. Send me a direct message on Discord. Okay. Let's get back to our code, you guys. We have about an hour left. Well, 52 minutes. We got 52 minutes. Good news, that's more than enough time. I would really like to... we might not be able to... So let's see here. I'm going to consult... Do you mean to pass a tuple to create a subarray? It's happening here. However, we don't have access to that code because it's coming in the Pytorch side of things. So we might need to be able to override that. Visible deprecation warning D-type align. Can we specify D-type? Is there a way to do a D-type? D-type equals torch.float 32. Can we do that? Is that something that we can do? Let's try it out. It doesn't like it. It doesn't like you guys. Thank you for the reactions. Appreciate it. You just finished your 30,000 hours build with your AI team. 30,000 hours is a long time. I think that's like, how many hours? 30,000 is a really long time. Are you sure it's 30,000? You're building to being a, being a biller is a different road. What's a biller? Actually, there isn't too much math. Matrices and a few other things. In the kernels, yeah. A lot of stuff used already solved for you. Yes, exactly, by very smart people. We don't have to write our own kernels unless you want to make a super mega kernel where you fuse everything together all in one go and you write your entire AI model in one GPU kernel. Well, maybe a couple GPU kernels, right? That is a good reason to write your own GPU kernel. And in fact, I did that before and I got it to run a lot faster. It done like this. Okay. Let's try it back over here. Let us get into, all right. So what I'm gonna do is, since I'm not able to deal with this here, let's close this, reopen that. Let's paste this in. All right. Let me go over to the code here. I'm going to copy, paste this here. Okay. Next. Paste, go. Okay. Let's see, let's get some answers here. Because I want to be able to solve this, and the problem is right here. It's exactly right here, and I can't do anything about it. Hey, I'll do it. Redless Saber, good to see you. Welcome on in. Happy Wednesday. We're going to continue with our Pytorch convolutional neural network tutorial. We're very close to having it in the training phase. The optimization phase. Thank you for the hearts, you guys. Thank you for the hearts. You do need sync points and kernels, right? You can sync purely on GPU so that it can be sped up potentially. I don't know about sync points. I'm not familiar with that. Newbie high-level language, yet the kernel from scratch, and yes, it was painful. I tried using Linux kernel for a separate distro. Oh, wait. We're talking about different kernels. There's two different kinds of kernels here, you guys. One's a GPU kernel, which is mostly, you know, a compute core shader, right? And it lets you specify code that will run on your GPU or accelerator. Or kernel, which is an operating system kernel, which runs all of your applications and things like that. Two different kinds of kernel. People are voting that AML is harder to code than operating system. It kind of is. It's a little tough because it can work. Here's the deal. Here's why AI is difficult. Are you ready? Strap in. This one's a good one. AI is pretty forgiving in a way that allows you to build a model that will work successfully. However, it can work way better if you build it better. If you can build it even better, and you didn't know that you could do that. Your AI can work somewhat, part way. It can work part way and still give you good results. If you write it differently or use different algorithms or a different approach, it'll be even better. That's why AI is hard. Because it's got this twist. It's like, oh, you thought you did good? You did good! You can do better though. But how? You don't know. You have to try a bunch of different things. That's why AI is difficult. We're talking about two different types of kernels, a CUDA kernel versus an operating system. Yeah, exactly. The sync points for kernel, you don't have an atomics or anything, so you need to read the result of a computation. Oh, okay, got it. For the termination, the end, the output. Is C# or C animating 1,000 layers is hard work done by multiple. One perfect AI is smart work by knowledge persons. Roshan, you got it. Yeah, exactly. That's why it's tricky. Sometimes you need to be crazy for CUDA kernels. Yeah, exactly. Crazy for CUDA kernels. You've got a great kernel. It's good for bottlenecks. I like mega kernels. I like the mega kernels. All right, let's pop over here. The warning's coming from Torch Vision's C4 Pickler, not from your transformer or D-type argument. I patched this. What? No, you're not supposed to edit anything. Load sarf wrapper that suppresses only specific version in a routed existing calls. I'm gonna overwrite that. Unsupported argument. All right, just show code. I'm gonna undo that. I don't want it to actually, that's why I couldn't save. Yes, okay, overwritten. It's overwritten. All right, here we go. Let's see, what is it? All right, oh, with warnings catch? Oh, that's dumb. I don't want to do that. I don't want any warnings catch. That's silly. All right, we're just gonna ignore it. Wait, hold on. With warnings, catch, warnings, filters, category. All right, I'm just gonna ignore it. We're gonna have a warning, and it's not gonna be. We're not gonna worry about it. We're just not gonna worry about it. Okay. CUDA will also let you call kernels from GPU, which saves on round trips. Really? Eon system scanned and got 7,000 layers from a fruit fly's brain. Oh, right, Eon, I saw that video. You want to do this? Yeah, you want that data? So you can do something. You want the fly's brain, right? That's what you want. Is there something wrong? It's not something wrong, it's just a warning, and it's annoying. Okay, so I think we could do this. All right, let's call this out here. We were just trying to fix it. We're trying to early optimize. It's not a big deal. Okay. Let me run this again, make sure we're all good and clean. See, this is the error right here. It's not an error, it's a warning, and I just wanted to get rid of it. Now there's an error. Here it is, right here. Okay. Waiting for your editing. Oh, waiting for editing something. Your code looks like JSON script, man. Does it? I think it's pretty clean. It's the 4th time now. For the For You page is rigged. Oh, hey, welcome back. For the 4th time, SQLiter. There's no escape now. You know, it's too late now. You can't escape. There's no way you can escape. Why do you want to get rid of the warning? Because I want perfection. I want perfection. Coding specifically machine learning models is easy. Scikit-learn. Yeah, exactly. Like the Scikit-learn. A Ryzen CPU. Which AI capabilities only scale with your specific hardware. Scikit-learn is not deep learning, right? So you don't usually need a GPU accelerator with scikit-learn. In fact, I don't think they have a GPU accelerator available in scikit-learn. Okay, I like that. Nice. Let me make sure this is running now and all good and to go. We're gonna go into the optimization phase now. You guys, are you ready? We're gonna learn. We're gonna have the AI model learn. Let's do it. Let's learn together. So AI is hardware and microcontrollers, and software drastically differs. Yeah, scikit-learn is also not the most efficient on CPU. It only has CPU. That's all. Oh, right. It could be more efficient on CPU if they built it better. Got it. I'm just gonna stay here. Nothing I can do to escape it. Exactly, SQLiter. You're stuck now. Let's add our criterion in and our optimizer. Okay. Let's do this. So, self.loss equals torch.inn.cross entropy loss. Like that? Let me double check. Yeah, I did it. Right there. We also have inn already available, so we can just go like that. So that's our loss. And then we're gonna have our optimizer, which we have to do outside of the class. We gotta do it outside of the class. So let's do that over here, which is gonna make it difficult to do this. So let's do our optim equals torch.optim. What was it again? Oh wait, hold the phone. I don't wanna use, oh yeah, stochastic gradient descent is fine. We can do that. SGD, and we can put the, where is that at? So optim is, do we have that up here? Okay, torch to optim, okay. Oh, wait, we're doing it right, optim. Yeah, we're making things work. It's working. Oh, you notice the keyboard below. Yeah, it's got a keyboard right here. So you can see when I'm typing. A lot of people were saying, hey, would you put a camera over your live keyboard? And we could have done that. I figured it's just easier to show you what's typing on the screen, so you can, instead of trying to figure out where my fingers are typing, you can actually see when there's a keystroke here. So if you're looking at what I'm typing from a Vim perspective, you can see what keystrokes I'm using. Accidentally typed twice, no worries. Fun fact, Neva knows to code pretty well, while I know absolutely nothing. Neva is fantastic coder. Neva's fantastic. Many years of help. Do you guys know anything? Do you have any idea why Linux is way faster and smooth in animation? Linux is just a better kernel and it's lighter weight. Also, on Mac and maybe Windows, it seems like they've got some sort of built-in obsolescence that slows older computers down. I've got an older Mac and an older laptop, a way older laptop. Like a 10-year-old laptop and a 2-year-old Mac. The 10-year-old laptop is faster with Linux than the 2-year-old MacBook. That's how Linux is. Linux is not vibe coded. Exactly. All right. Optim.sgd. We're going to say we need this over here. We're going to say Linnet.parameters. Is it parameters? Forgot what this is. But yeah, it is parameters. And then we're going to say learning rate equals Linnet.learning rate. And then we're going to say momentum equals 0.9. All right, that's our optimizer. And then on our train, we're going to ask for the optimizer to be defined here. Optim. So we'll have that right there. Goodbye for now. Gotta go get coffee. All right, nice monkey man. Good to have you here. Enjoy your coffee fix. You can get garbage collection clean fast enough to run out of memory. Oh, so you can get the GC not clean fast enough, and then you'll run out of memory. Yeah, okay. That's one way to do it. You get those out of memory errors, the ooms. If you ever heard someone say that's what out of memory is. Okay, let's keep going. You can't fully depend on Linux because some hardware software required Windows. Oh, well, hey, in the AI world, most of the time, it has been developed on Linux. Back maybe 10 years ago, it was like the premier way to run AI models was on Linux. And in some ways, it still is. How do you get into the game development? You pull open something like Unity. Armored, you go look into Unity. It's called Unity C#. It was a good starting point. Or Godot. Godot is another one. It's an alternative. Just play games. World resident. Yeah, I see what you're saying there. You can just play the games. Okay, so we've got our optimizer here. I believe we're ready to go. We've got our criterion, which is our loss. Optimizer is what drives the learning. If you didn't know this, guys, the optimization, when you're talking about optimizing a model, this is actually the part where the AI learns. The learning phase, it's actually going to make understanding. It's going to derive meaning and understanding from the data that you feed it. This is the optimization phase. All right, how many epochs do we have? We've got self.epochs, okay. For self.epochs, I think we got epochs here, yeah. Epoch in range. Okay, let's loop in. Let's loop in, you guys. Now we're gonna get our data. We're gonna get our data loader. Oh, okay. Running. Let's see our losses. I'm just gonna call this losses equals. I suppose we could just do a 0. We can do an average over it, or 0.0. Or cost. I'm gonna call it cost. I'm gonna call it cost. It's not quite fully cost, but we're gonna call it cost. Hey, Zuriel, thank you for subscribing. Appreciate it. Good to have you here. Welcome on in. You joined the right channel for software engineering. We're going to be building ourselves an AI that's going to learn. This is called computer vision. It's a convolutional neural network. It's going to be. It's not the world's premier, most advanced model. There's now something called vision transformers, which gives you a little bit different approach. We're going more the traditional route because we're going to make sure to learn all of Pytorch, becoming Pytorch experts. Become Pytorch experts with me. Let's do it. All right. So we're going to running loss, which I'm just going to call the cost, and we're going to enumerate our data loader. So let's do this. All right. So let's see, data, comma, labels. Sport programming. Hey, do you actually do sport programming? What kind of sport programming do you do? Thank you for subscribing. Welcome on in. Glad to have you here. Let's become AI experts, you guys. Labels. We'll call this in features. We're going to call this features and labels. So features, right here, this feature segment, that is the images. This is going to be the images. So that's features, images. Labels are going to be the actual, what they actually are. Is it going to be a cat, a dog, a deer, a frog, a boat, a car? It can be a lot of things. Like transformers are more flops. than you would think. CNNs are nice and fast and learn well with less data. Okay, our transformers are going to be a little bit more advanced than in that case, yeah. Arguably, VIT is worse performing according to some papers that counted flops again. Can you do the new OpenAI challenge and create a tutorial from it, please? What's the new OpenAI challenge, Turt? Hey, Turt, thank you for asking about that, Turt. What's the new OpenAI challenge? OpenAI challenge? What is it? Is this it here? This is old. Is there a new one? Is there new? See, starter pack checkpoints. I don't, yes, research papers. I love this. Hey, Anasazi. This is my sport. Nice. Me too. It's called parameter golf. Okay. Parameter golf. We know good ideas when we see. So we're hosting an open research challenge to build the most efficient pre-trained model under extreme constraints. Minimize held out loss on a fixed fine web data set. Okay, so they're giving us the data and we need to minimize the loss while staying within a strict 16 megabyte artifact limit, weights plus training code combined. Okay. And a 10-minute training budget on 8 H100s. Okay, got it. That sounds like a lot of fun. I think we could come up with something that would be pretty interesting. I think we might be able to make it into like maybe the top 100 or the top 10 maybe. We might be able to get in there. We might be able to get in the top 100 or top 10. We don't have to do this now. We don't have to do this now. We could do this later. Even after they, close the parameter golf. Train the smallest LLM you can that fits into 16 megabytes. Best model wins. Hey, there we go. This sounds like a lot of fun. What do we got here? Data. Oh, okay. Very big data. Okay. All right. 8 H100s is moderate training setup. I believe it's around $1,000 a day. Whoa, really? $1,000 a day? That seems like would it be $1,000 a day? It seems pretty high. I think it would be more like maybe 50. It can't be $1,000 a day, is it? Because I've opened up this before. I've launched 8 100s machine sizes before, and I don't think it was that expensive. You like how many float operations you have to do? That's a lot of float operations, yeah. You really like to see that. Thanks for checking it out. Turt, you're welcome, Turt. I think this would be a lot of fun. I think we could do this. And before we get into it, though, the opportunities right now, right? The opportunities right now for us to do this. Clone, data path, find web, tokenizer path. Do we have to use our tokenizer? Vocab size. Torch run standalone. By default, it keeps 10-minute wall clock cap. If you want to go longer, override it explicitly. By default, this command train loss, step log during the training, and prints out val loss, val BBP, and compressed model size. Okay. What exactly counts? Okay, no big deal. We could do it! We could do it! We only have 30 minutes left. We only have 30 minutes! And so I'd much rather finish the tutorial, because we're like right there. And I feel like I would be giving up if I didn't finish the tutorial. It is running Torch. It says Torch run. Do they have here we go. Let's look at the libs here. Yeah, all right, so we got Torch, Hugging Face, kernels, setup. Hold on. There. Okay. Back. Nope. Thank you. Okay. So yeah, I don't do my paper stuff until uni. Somehow lucked yourself into the second year research of a good uni. Hey, always good lucking yourself into it. What's the reward for winning? Win. I don't know. Okay, and winning approaches may be featured publicly. That's it. You just get notoriety. Do you guys want notoriety? This challenge is designed to surface exceptional researchers and engineers we'd want to hire. Stand out and participants will be invited to interview. I don't want to interview though, because I already have my own company. I'm good to go. We don't need any of this stuff. And winning approaches may be featured publicly, so you get notoriety and an interview. You get notoriety and an interview. Maybe, I don't know. Very unlucky in other places. Hey, it's all about being present, being alive, being around, and being active, and participating and proceeding forward. If you don't act, it's a guaranteed failure. So lucking in is kind of the only way things work, really. Because if you don't try, it's a guaranteed failure. Steven, you can do it for the clout and for the fun of it. I know, I think it would be fun. I think it's worth for some people. Let me... Oh my goodness. Okay. All right, let's clone it. But we don't... So the problem is I'd have to spin up some H100s. We also know compute is expensive. OpenAI is sponsoring $1 million in compute credits to help people get started with training their models. To request a compute grant, use a request a compute grant. Okay. So we have to do some setup here. If we really wanted to do this, we would need to... Is this the baseline? Okay. Is there a baseline file in here? Train GPT. Oh, wow. Look at that, you guys. It's pretty. I'm stunned. I think it's very beautiful. Muon. Tokenizer agnostic evaluation step. My goodness. This is not a short thing. I fell asleep, guys. It's 12:36 a.m. GG's Rosin. Thank you for stopping on by. Good to have you. Enjoy the sleeping. This is going to be a bit much to go through. Obviously, it's a GPT. It's a transformer. Everything all right here in one nice giant file for us. And it wants us to improve it. So this is the file we have to improve. They want us to make it better. And here's the alternative. Oh, they have disk that nightmarish. Yeah, it's a lot of stuff. All right, so we have, how much time do we have here? So we got 25 minutes. And this would take a lot longer to get going. Obviously, they've got the baseline here, and we need to see what the baseline is. We got to run it. We got to spin up the H100s, which would be expensive. What's the link? Okay, yeah. Here, I'll post the link here real quick. Like here. It's called Parameter Golf. I'll put it on Discord. So we've got it under our link share. So it's there forever. Here we go. And I'll give you the link to the Discord real quick. So that way you can reference it anytime you want. So add on Sazi. Here you go. Discord. Off to the races. There is sync stuff because it's 8 H100s. So you want to check out the distributed training tutorial. Got it. Okay. It's not for the faint of heart. Oh, okay, got it. Yeah. I mean, I figured. Well, it makes sense because you have to run it. You've got the layers, and they said it's only 16 megabytes. So why would you need H100s for 16 megabytes? You don't need H100s for 16 megabytes. You don't. You might need it for like the dataset though. The dataset's pretty big, right? Data workflow directory. Okay. All right. We had fun with that. We'll look into it later maybe. We gotta finish this though. It's the iter our self dot training. Where's this at? Train data loader. Here we go. Okay, I think that's it. Let's do print labels. And you parallelize over the GPUs and then sum the gradients. Oh, so it can do it fast. Got it. I didn't even think about that part. So, okay, that makes a lot of sense. Okay, that's perfectly fine. Got it. Okay, that's perfectly fair. You also need to run the model on more than one GPU. Neva, thank you. That's actually really helpful. Understood. Now we got it. It helps you parallelize your training so it runs really fast. So it makes it run really, really fast. Got it. Okay. We're just gonna keep things simple real quick. Okay. So we're gonna do a train. Train optim. Okay. It's not called self.train, it's called Lynette. All right, let's run that really quick. Did I return it? Epoch. Self.epoch isn't a thing. Okay. Oh, I gotta spell things correctly. That's why, you guys. That's why. We gotta spell things correctly. Okay. Lynette object has no attribute train loader. Okay. It's called train data loader. Okay. I'm gonna change this to say train loader. There we go. Okay. Nice. And I think that's it right there. Okay. So where's our train at? Here we go. Train loader. Perfect. Okay. On larger models, you would need to split it like layers. Each layer gets split. Pairs and pairs to run on a copy. Or is that globally? What? Globally? What are you talking about? Okay. All right, you guys, we got very little time left. Very little time. Let's get into this. All I want to do is make sure that we're getting our loss. This is it right here. This is the last bit right there. That's all we got to do. All right, let's get our outputs, our gradients, optimizer. Okay, so we got our data, or enumerating. So we can enumerate our data. We could do this. Can we? Hold on. Okay. I suppose we could do this. Let's do that. Iterator. Oh, yeah, okay, we're doing that. This is what we're doing. I like this better. This is nicer. Where was that at? Iterator. Wait. We just saw it. Where'd that, oh, wait, no, we use it here. Okay, got it. Okay. Perfect. You know what we could do is, we could say iterator equals. Keep things clean. Keep things clean like that. Okay. So we're gonna go return. Let's try this. Okay. Labels. Pluralize it. All right, you guys. Okay. Hey, there we go. All right, now we're on the right track. This is where we want to be. Okay, perfect. So that's our output. That means that we've got our data in the shape that we want. Is it a float? It's a float. Okay. And we've got our images right here. Nice, pretty, beautiful images. And then we need to run it through our optimizer next. Okay, so we're gonna say optimizer. So our optimizer is called an optim. Optim.zeroGrad. Was he? Zero grads. Okay. Zero the gradients. Then we're going to get the output. Out equals self.forward. And then we go the images. and that gets us the output. So let's print the output here. And that should look similar to the labels. Let's do an F print here. Labels. There we go. And then we'll do the same thing. We're out. Well, no, never mind. Let's just do it like this, because otherwise it's going to print it weird, and I want it to print normal. Okay. So that looks good. Let's run one iteration. Let's run one iteration. Okay. What? Hold on. That should have been fine. Why is that not happy? Linux train optimizer. Optim. It doesn't like that? Wait, why is it not like this? Let's see here. Where's our error? Where's our error? Everything was working fine. It was all working fine. Why is it not working now? La la la. So let's do return here. See self.train. Can we do self.train? I suppose we could also do self like this. I think we could do self like that. Self.train. Okay. Nope. All right. Missing one required parameter optim. Oh wait. Oh. Okay. Here's what we're gonna do. Here's what we're gonna do, you guys. We're gonna make it different. We're gonna take a different path. We're just not gonna have this. We're gonna get rid of that. Okay. So this will be Linnet.train. And instead of saying return, we're gonna say break. Okay. This is our training phase. Here we go. Wait, did I miss some stuff up? Yeah, okay, so we don't have self anymore. So this is gonna be Linnet. There we go. Like that. Perfect. Okay. Did we fix it? Oh, we fixed it. All right, perfect. All right, you guys. All right, we're on the right track now. Okay, so optim zero gradients is going to be able to optimize, turn off the gradients for our back propagation. No errors, no errors. Hey, we're looking good. We're looking good. Nice. Yeah. I was like worried about it. I'm like, oh no. We only have like, what is it? 17 minutes. We got 17 minutes. So I think let's go through one training batch and find out here. We should get something on the screen. It should look good. Oh no. Okay. Given one group weights expected input, have one channels but got 3 channels instead. We are only supposed to have one channel. Did we mess that up? Did we reduce it? We didn't reduce it right. The villain music too. I know, Forerunner. I know exactly. Are you using cross validation? Yes. Yes, we are. Well, we're using cross entropy loss. Cross validation is more of the testing phase, is what you might be talking about. And we will be doing that tomorrow. Today, though, we're just trying to do a regular training session. We're just gonna do regular training. Nothing fancy. Nothing fancy, you guys. Okay. So this part, so that's our image data. We get our image data here. And what we're missing is potentially our transform needs to be, so that's our normalize. And we need to convert it into one color. Or why not do 3? Why don't we go above the tutorial and make it 3? Why don't we do that? You guys, why don't we just do that? Let's make it colors. Red, green, blue. Why don't we try that? Instead of getting rid of the colors, why don't we just use the colors? Let's use the colors to our advantage. Let's see if that works. Oh, I hope it works. Please work. It might work. Oh, there. Okay. Wait, one step closer. Okay. Ooh. Oh, it worked. Oh, it worked, you guys. It worked. Oh, okay. Ooh. Hey, there we go. Okay. Hey, look at that right there. Hey, we're going beyond the tutorial now. We just took it a step further. Not only are we using one hot, we're also getting every single color channel. We're not throwing anything away here. Nothing's getting thrown away, you guys. We're eating every part. No parts of the vegetable go to waste. Yay, this is great. This is great. Okay, I'm really excited now. Okay, so I should be able to start printing out. So we don't need this anymore. We don't need that. We should do the cost. All right, so let's calculate the loss now. Equals our loss, Lynette.loss, and we're going to do our out and labels like that. Let's print the loss and break. There we go. All right, so we should see a floating point number. It will be really exciting. What's Lynette? It is my name for a computer vision model that's going to classify and be able to identify pictures of 10 different classes. 10 classes. The classes are going to be right here. It's a plane, or, right, see, it's a plane, or car, or bird, or cat, deer, dog, frog, horse, ship, and truck. So that is the classes. And we're calling it, see, Lynette, right there. Lynette, right there. Okay. So this is our optimization phase. Let's make this pretty. So this is like important, you know, we know this is important. Make some pretty important stuff here. All right. Paste. Important optimization phase. The model will begin to learn here. See, look how simple this part of the code is. It's only a few lines of code. If you were to look at the rest of it, all the rest of it is data preparation. It's ridiculous. And this is the actual AI learning part. We haven't finished yet, so we have to calculate the gradients, and we need to apply the gradients. So our loss.backward. The backward? Yeah, backward. Calculate gradients. And then we need to optimize. Optimize.step. Apply gradients to model weights. Like that. Do you save the best parameter somewhere? Hey, yeah, this is a lot of fun. So what you can do is, when you're building your model, initialize the parameters as random parameters initialization. Then you shuffle your data. And now and then use stochastic gradient descent during your training phase. Everything's randomized. So you've got this nice big fuzzy bundle of data that's going through. Every time you train the model using this approach, it's going to give you a different model output, which is pretty neat. I think it's pretty neat. That means that you train 100 models, one of them is going to be better than all the others. If you train it 100 times, one is going to win. So you can do a whole bunch of fun things, training the model 100 times and saving only the best parameters. Yeah. HS, I'm not sure if that's what you were talking about. We can do that though. We can do that. Now let's calculate our cost equals cost plus loss divided by 2. Like that. And then we should print our cost is what we should print. Here we go. Good deal. We should also print out our current epoch. So let's do this. F cost :dot to F cost. And then we will do our epoch. Is epoch plus 1. There we go. Perfect. Do you use metric on the validation set to choose it? Yes, we do. We do lowest loss and highest accuracy. So you can do both. So you want like low loss and high accuracy. So you've got your test data. You run it on the test data. You want to get the highest accuracy as possible, and so you pick the winner on the highest accuracy and the lowest loss. Fuzzy logic is great, sure is. Like that fuzzy logic. That's what AI is. This is why researchers will tell you, hey, check this out. We don't actually know what's going on in the AI models. We don't know how they work. That is not true. We kind of pretty much know exactly how they work. We just don't know what's happening on the inside with all the if statements. Every parameter is like a single if statement, right? You've got a bunch of numbers. Let's take a look here. So this is what a model looks like. You get all these numbers. These are what parameters are, right? This is 1, 2, 3, 4 times 3 is 12. This is 12 parameters. It's a 12 parameter model. Now, when you talk about ChatGPT, that is like a trillion parameters. So it's a trillion numbers, right? Trillion numbers. A lot of numbers. Each one is essentially like an if statement. Will the number exceed the threshold to proceed onward? You can kind of think of it like that. It's not exactly like that. It's kind of like that. And so you want to make sure that when you're running your model that you're seeing you're just like, what's going on? You're saying like, what's even happening? I don't know. This is what all the scientists are like. We don't know what's happening. We don't know what's going on inside the AI model. The fact is, we understand the math. We just don't know how to predict what the model's going to do because there's a trillion parameters in it. How can you possibly predict it? You're not supposed to. So that's why they say we don't know what's going on inside of models. In fact, we kind of do. We kind of do know what's going on. We just don't know what they're going to do after we've trained them because there's a trillion parameters and there's no way for us to predict that. Unless we have a trillion parameter model that's able to analyze the trillion parameter model, then we might have some understanding on it. You learned some new things from watching you, and I'm sure you're not sure if you'll remember. I've learned it, right? You might remember it. Hey, that's the way we do it here. We do a bit fuzzy. What does make it fuzzy, but it still works for the same? Yeah, the randomize. You want to randomize it. So you add some random. You want to shuffle your data, shuffle your parameters that are initialized to make those random, and when you're doing stochastic gradient descent as well. For imbalanced data set, you tend to use F1 score rather than accuracy. You know what? The F1 score is very close to accuracy. It's not far off from accuracy. It's just very close to accuracy. I was surprised. I was like, have you guys used the F1 score before? The F1 score is really important. I'm like, well, are you sure about that? You really sure? Okay, let's try it out. We tried it. It's nearly identical to accuracy. There's not much different. There's a smidge different. It's just not that much different. You don't need trillions of parameters. We have some papers changing specific neurons to make models talk about bridges and all the time, you guys. So we know about specific parts of the brain. We sure do. I knew it. You use fuzzy logic in your kernel. Nice. You're building it proper. All right, you guys, is it gonna work? Is it gonna work? I think it will work. I think it'll work. Oh, there it goes. Okay. Here you go, guys. Now here's the ultimate question. Will it learn? All right. Will the loss drop below 1.0? That's the question. Will the loss drop below 1? What do you guys think? I think the answer is yes, because we've got enough data and we've got the correct model shape. It could also explode and go the opposite direction completely. It might explode up to 100 or infinity. Hey, Selly. Good to see you, Selly. Welcome on in. Happy Wednesday. Yes. Yes is the answer. Everyone's very confident. Y'all are very confident. All right, one moment. All right, so let's do epoch, batch. Let's see here. Oh, wait. There's a problem here. I see a problem. We need an additional iterator. We need an additional iterator, you guys. All right. Wait. We're gonna fix it. We're gonna make sure. We're gonna do everything we possibly can to make sure that your correct answer is gonna be yes. It will be. I believe in you. All right. So we have to do one thing because the loss might not go below 1 because it's only gonna go for like 4 epochs or something. How many epochs? Is only going to do 10 training batches. That's the number of batches. We need to do epochs. We got to do epochs. So we're going to have to enumerate. We got to enumerate. 1 second. We're gonna make it work, you guys. We're gonna make it work. Let's see. I want this right here. La la la. Test simple. Where's our train here? I really want to do here. Data loader for XY and the data loader. Ah. Okay. All right. 1 second. 1 second. So we have to do a for in on the data loader. Is what we got to do. Okay. Let's do that. C4 in. There we go. There we go. A little bit better now. A little bit better now. Okay, here we go. Let's try that. Perfect. Now we're onto the right path here. Perfect. Okay. Pretty. It'll do. All right. So if y'all changed your answer, perfect. Is it? Selly, you think that looks good? I think it might. If there's an error, don't worry, we'll fix it. The question wasn't whether there's an error or not. It's whether our model and our training cycle is gonna go below 1 on the loss. Here we go, you guys. Moment of truth. Is it gonna work? Here it goes. Oh, it's gonna. Oh, wait. No, that's not a problem. Wait, that's not a problem. Hold on. That's not a problem. That was a bug. That doesn't count. It doesn't count. All right, here we go. Oh, it's trying. It's only on the first epoch, though. Also, it's printing out a lot, and it's not running on an accelerator. So our batch size is a problem. Oh, I think it did. I think it dropped. Hold on. Did it drop? Hey, look at that right there. Yo, whoever said yes, you win. It dropped. That counts. I'm counting that right there. I'm counting it. That counts right there. Freeze frame. It counts. You guys. It worked. Oh, yeah. This is AI. We did it. It counts. What's the loss here? Accuracy by percent? The loss is just whatever we get from this right here. The cross entropy loss. That's what it is. How big can a model get until you have to pay to make it bigger? What do you mean? What do you mean you have to pay? You have to pay to make it bigger always. It counts. You got it. Anasazi, you're right. It counts. AI is cool, Stephen Blum. Yeah, Selby, I think so. Selly, I agree with you. Selly. AI is cool. All right, we did it, you guys. We did it right there. You can see it works. It's doing pretty good. How many? We have 10. Okay, so we get 10 epochs. This is running purely on CPU. So what we should do is, we have a few chances here. We should run this on an accelerator, you guys. Yes, it is. Thank you for the hearts. Appreciate it. So glad you guys are here. Look, we did it. We achieved the goal. Now let's go one step further. Hey, Oleg, good to see you. Welcome on in. Happy Tuesday. We are training our convolutional neural network, and it's working. You can see there whenever it flickers 0 on the screen. Oh, we did it, you guys. I'm so happy now. Oh, now I can have a good day. We did it. So many fun things to do. Keep going with career. Yeah, exactly. We're going to make that happen. It's happening, you guys. This is so good. All right. So what is the final cost going to be? It seems to be random between 0 and 1 right now. Between a little bit below 1. Oh, here's the last epoch. Here's the last one, you guys. You see zeros rolling now? You sure do, Anasazi. My B, you got it. It's working. Yes, we did it. It dropped below 1. That's the answer. Yes is the answer. Okay. Hey, all right. So where do you see on the screen? Hold on. Wait. La. You don't see anything. All right, where is it? Here. All right. I see a bunch of zeros in there. Right here. Okay. Right there, you guys. Right there. That counts. Bunch of zeros. All right. Okay. So, what I'm going to do next is, let's bump up the learning rate just a smidge. And then, hold on. What did they say the learning rate was in the tutorial? LR equals 0, 1. Okay. So it was about that. Okay. I'm going to bump it up a bit. Just a smidgen. Okay. Just a smidgen. No, you did, and we did it together. Yeah, we sure did. We did it together, you guys. You helped out. Let's see if we can make it a little bit better. Now I'm going to be moving these items into the, where is it at? All right, so we're going to be moving these items to dot to device, and we're going to define the device. So let's do this. Self dot. Let's grab this. We're going to grab it from here. Device. Right here. Okay. And we're going to put this up here. We'll put it over here. Right here. So we got our device. We got our accelerator right there. We got our accelerator, and then we're going to move the model and all the data over to our accelerator. So that way it goes faster. Okay. Device right there. Perfect. Okay. Okay. Let's make it go faster, you guys. Let's make it even faster. So the net dot to, wait, is it called to device? Yeah, I think it's just dot to. What's dot to? Device. Like that. Okay. Then we need to do the same thing for our images and labels. All right. Images equals images dot to device. Like that. Oh, wait. We already did that here. We don't need to redo it. Whoops. Okay. Dot to device. Like that. There we go. I think that's it. Okay. That should do the trick. And then I also want to, let's do a little bit extra stuff here. I want to be a YouTuber when I grow up. Hey! Maybe we can collaborate together. Sally, sounds good. Sounds good. Join the Discord and we can chat further. Someday. YouTube is the way to go. Hey, how's it going there, Jacob? Good to see you, Jacob. Welcome on in. We're about to optimize our AI model, which is the training process, right? This is where the AI actually learns. And we're going to use our accelerator. And then we will call it a good greetings. Hey, Suit Billy, welcome on in. Gray, thank you for saying hi. Welcome on in. Also, everyone, Jacobs. Okay, sounds good. Let's see, batch. All right, so we'll say batch equals 0. And then we'll say batch plus equals 1. So we increment our batches here. I'm gonna put this over here though. If batch mod 100, if not batch 100, print it. Okay, like that. So that way our screen doesn't explode with a bunch of stuff. So we can see it a little bit better. A smidgen better, you guys. Oh, do you play Roblox? Are you saying Roblox? I play Minecraft is what I play. Oh, good luck. Thank you. I appreciate it, Sally. Do you play Roblox? Yeah, I thought you said Roblox. Minecraft. I do Minecraft. I like Minecraft. Let's see here. Okay. Let's see if that works. Self dot. Where'd that at? Did I mess something up here? On line 26. Get rid of that. Okay. Oh, me too. Nice, Sally. Okay. Here we go. Final. Perfect. Yeah. All right. That's what I like to see. Okay. We did it. Although I want to see a better learning. And is that batch not big enough? The batch isn't big enough. I need a bigger batch. Let's go batch size of 64. Let's go bigger batches. Gotta get the bigger batches going. Here we goop. Yeah, here we goop. All right, now we're into it. Okay. Our loss isn't going down as much as I want it to, although it does kind of look like it's going down, just not nearly as much as I want it to. How's it going there? Oh, Niho, who'd you? I see what you said. Okay, nice. Oh, there's a 0. It seems okay. Okay. We're seeing a few more zeros in there. My brother went bananas when you said to play Minecraft. Really? I love it. I love Minecraft. I play a lot. I play on the weekends usually. You went larger, so cost may be same. Got it. Anasazi, understood. Let's see. Oh, we got a couple of zeros. That's good. It seems like, okay, it seems like we're now hitting in the ones and zeros phase. Like we're not hitting twos anymore. So we actually are learning. We are learning. Hey, that's looking good to me. We're actually learning now. I see what you said over there, ni hao? Are you saying ni hao? Is that hi? You're saying hi? Okay ho. Okay ho! Yeah, I saw 1, 2. I saw 1, 2 in there. Okay. Seeing all the things. Oh, it's looking so good, you guys. Looking so good. On the 4th epoch. Thank you for the hearts. Why are people online sometimes? Oh, yeah, I know, right, Neva? I know. It's the internet. That's just how it works. Okay. So we might need to optimize. Okay, so here's the plan. The plan for tomorrow is we'll optimize it and we'll test the data to see that it actually has outputs and results. Jacob, thanks for saying hi. Selby, what do you mean, Selby? Oh yeah, sorry, you didn't see this. So there are some chat messages that show up that you guys can't see. That's probably what the deal is. All right, for real, I know it. All right, we succeeded. Thank you for all the hearts reactions, you guys. Appreciate it. This is a lot of fun. I love this. This is great stuff. So we made there's a really good one. There's like a 0.85 right there. You see that? There, right there. A nice, really low one. That's a really low one. I wanted to consistently stay below 1 though. And it keeps popping up. Which is a little rough. I want it to decrease a lot more. Maybe we can increase the learning rate. Let's try this. Let's go a smidge higher. Make it increase just a smidge. Let's do 0.5. You need a lower learning rate. Oh, it's got to be even lower? Okay. And regularization. I suppose so. Yes. See you when you go live tomorrow. Hey, Selby, thanks. Sounds good. 5 times. 5 times more. Okay. I'm going to close that, and I'm going to try just a smidge lower. So we're going to go lower. And we'll increase the density to 256. So it's a bit more. And then our batches will be 128. Because we've got the power. Also, larger batches can help. Hey, we just did it. We did larger batches. There you go. All right. Yeah. Okay, it starts out high at the 2s. It went dropping down the 1s now. All right. Seeing a little bit more smoother now. A little bit smoother. You like learning? Me too, Sally? Me too. Hey, how's it going there, Gold Prospect King? This is alien to me. Coding. Is it? Well, that's what we do here. We do the coding. And we're training an AI on convolutional neural network. We succeeded. I'm liking the numbers well enough. I'm liking them enough that we're at the point where I can say, we did pretty good. Also, we should try Atom W instead of SGD. So let's try that. SGD. Let's try Atom W. Let's try that. You have a question. What do you got? What's your question? What'd I miss? Oh, Loons. Good news. We made it work. We got the model to learn. Oh, wait. Atom W and it got a keyword momentum. It doesn't like momentum. All right, fine. We're going to get rid of momentum. Let's do that. Well, fine. Here you go. There's no momentum for you, Atom W. Happy now? There. Your new hobby is 2024. You started gold prospecting. Ooh, very nice. Hey, all right, looking good. All right, I want it to drop continuously. A nice smooth drop. Down. I want it to stay down. I want it to get below and stay below 1. Not just drop below 1 every now and then. I want it to stay below 1. All right, it's doing okay. Oh, we got a couple. Okay. All right. Okay. Well, let's see here. All right. So, Sully, what's your question? So, can you hack Jack Doherty? You mean Dorsey? No, not really. I mean, there is a way to do it, and we're not going to do it. We won't do it. We won't talk about it. I always had this question, what's the purpose of NumPy? NumPy is a nice math library, especially when it comes to arrays and array manipulations. I really like NumPy. It's one of my favorite libraries. It's really powerful. It makes it really easy to iterate over multiple data sets with a very few number of lines of code. It's like sort of a really nice framework that helps you do a large amount of work really easily. There you go. Dorothy. Oh, it is Dorothy. Okay. Would it be a pain to print mean loss per batch instead of just the final, so it's less noisy? It is kind of the mean loss. Here, I'll show you. Here it is. It's kind of the mean loss, yeah. What we could do is we could do true mean instead of the average, running average. We could do the true mean. So we could do that. Let's do that real quick. All right, so let's do losses equals array, and we'll say losses dot append loss, and then we'll say sum losses. Here we go. Okay, like that. Let's try that. Although I was looking, I've seen a lot of zeros there. I'm seeing a lot of zeros. I'm liking that. I'm liking that. Uh-oh. I forgot part of the trick. That the cost is not going. It's going the wrong direction. All right, 1 second. Hey, how's it going, Sally? Oh, hi. How should I start learning coding? I recommend at least looking at some YouTube videos just to see what's possible, and then immediately jump into your IDE or your text editor and start writing code. Immediately. Start writing code immediately. Even if you're just typing it from the website somewhere, you got to write it with your hands. Thank you for the hearts, you guys. Appreciate it. Okay. Let's see here. Divided by len losses. Okay, now we're good. Now we're doing the mean. Okay, here we go. Oh, just kidding? List and int. Okay, fine. Float. How about that now? All right. You're welcome. Oh, thank you. Appreciate it. Oh, wait. What are you talking about? List and float. Oh, I see. I'm being silly. Hold on. There we go. Now it's going to work. It's going to work now. Right? There we go. This is the actual running loss. Ooh, it did improve. And look at that. Okay, that's way better. Thank you for... Who said that? Forgot to divide the len by losses yet? Who said that? Hold on. Wait. Dorothy. Gotcha. Dorothy. Would it be a pain to mean loss? Hey, Rowan Morkner, thank you. Look, Rowan Morkner. Oh, that's what I want right there. I like that a lot better. Thank you, Rowan Morkner. Thank you. You win. Gold star, Rowan Morkner. It's smooth now. Yeah, it is. Thank you. I saw something on YouTube. It claims that it can view your hidden password and inspect. Is that true? Yes, it depends. And found password and then leaves the quotations. And it should show on the screen for me. So there's a couple of ways to go about that in that case. There's a couple of ways. Do you mean Jack Doherty? I thought that's what you guys were talking about. All right, you guys. This is very satisfying. This is what I wanted to see. The average didn't go below, although there were batches that did go below 1, and I count that. What are we doing right now? Hey, Rival Sebastian, we just built our own AI model, and it's going to be a CNN, simple CNN right here. So if you see, there's our layers, here's our forward function, and we trained it on some sample data here that we loaded called the CFAR 10 dataset, which is a bunch of pictures of planes, cars, birds, cats, dogs, frogs, horses, ships, and trucks. Things like that, cars and things. All right, you guys. The plan for tomorrow, we're going to be testing the training data. So we're going to train the model, and we're going to run it on test dataset and see how accurate it is. Obviously, it's going to take a little while to train here because there's a lot to train on, and it requires a lot of work. All right, guys, thank you so much for joining. We'll be back tomorrow. Appreciate it. See you tomorrow, guys. We'll be back tomorrow. We're going to be testing the model's accuracy. That's the plan for tomorrow. We'll be back. Bye, guys. See you tomorrow.